A good turnout after the late finish last night, but I'd like to thank Arlindo and the whole team for inviting me back to speak at Diving Talks again. A theme that I've noticed through yesterday's talk is citizen science. A lot of people are talking about it, and for me, one of the things that I think will be a factor that inspires the next generation and brings young people back into diving is creating a purpose for diving. I've been diving 35 years now, and I went professional after my first year of diving because I loved it so much. But I always wanted something to do on my dives, not just jump in, swim around, go do some fish. I wanted a purpose, whether that be photography, videography, survey, exploration, didn't really matter. And so that evolved and grew. For the last 3.5 years, I've been working in a research role at Deep, that Kirk is going to talk about later this morning. But prior to that, for a decade, I worked as a dive safety officer in scientific diving. Now, that was a professional scenario where I was being paid to do that job, and that involved mostly maritime archaeology, from the ancient, from 200 BC through to the modern, World War II. But what I started to learn was there was very easy ways to integrate normal recreational divers, from the single tank scuba diver through to the highly experienced rebreather diver, into some of these projects, whether that be marine biology or maritime archaeology. So a very good friend of mine, he put together an idea that we could help the universities in the United Kingdom to receive data that they couldn't get by any other means. And he put together a project to visit this remote area of islands off the northwest coast of the United Kingdom. Fingers crossed for the technology. Excellent. So we went to the Sea of Hebrides in 2025 in April. Now, anyone who's dived in the UK, especially in the northern reaches of Scotland, they will be aware that this is an extremely unpredictable area for weather. Once you get to the outer side, the western side of the outer Hebrides, this little tiny chain of islands on the left, next stop is America. So you've got the Atlantic, and it builds and it swells and it comes in. These islands are no protection, so the swell comes round the edge, and this Sea of Hebrides in the middle has notoriously bad weather conditions. You come across to the islands that come up the west side, so there is Rum here. We then come into the Sound of Mull, which is a long channel that links through to the mainland at Oban, and other freshwater locks that become brackish and eventually become sea locks are exiting here. So it's a very, very diverse region from a point of view of habitat, from a point of view of nutrients, but it's also a very high energy area. So you can often visit this place and get no dives at all. You spend an awful lot of time on one of the islands hiding in the pub, which is not so bad, but it's not what you go for. The yellow dots were the hopeful sites that Tim, the expedition leader, put together of places we might want to dive. And what was it we wanted to achieve? We wanted to go into a zone that is known as the Twilight Zone. It's known as the Twilight Zone because scientific divers traditionally will dive from 0 to 50 meters on scuba, whether that be professional, using some legislation, or whether it be amateur. And then we go to the world of mini submersibles, and these things are expensive. So putting them in deep water that they're made for example, something like the Triton submersibles, the 3K3, it's 1,000 meter rated. Hugely expensive to purchase, to operate, and to run. So to put it in 60 meters of water is kind of like underusing an incredible tool. So pioneers like Richard Pyle and Sonia Rowley have been diving in this zone from 50 meters up to and including 200, but mostly in that sweet spot of 100 to 120 meters to do science that prior to this has not been achieved. We used a boat called Closina. It's an enormous boat. Those of you that have dived Scapa Flow in the Orkney Islands, it's very similar to the traditional trawler that is converted into a dive boat. They fit a hydraulic lift on the side so you don't have to climb the ladder at the end of your dive. But Closina is double the size, so she's a huge working platform. Getting ready for one of the dives there, on my left-hand side is myself. Tim Clements in the middle. He comes from a background of maritime science. aquarium manufacture and stocking, and then fisheries protection. And then Hugo on the right is our three-man team. We were using mixed gas rebreather. We were using it in the hypoxic range. So the aim was to dive the sites that you saw on the previous from the yellow dots by using current technologies and diving within the qualifications that are available. Now, very importantly, this is a project in the UK. In the UK, we have a body called the Health and Safety Executive, HSE. Other countries have similar. For example, in America, it's OSHA. They're a body that control the legislation of professional diving. And under HSE, they will actually have a method to dive commercially with a helmet, offshore with a saturation system for oil and gas, commercially with a helmet, inshore with air surface applied, and then also for media, for recreational tuition, for scientific diving. So if you were doing this paid, you would be dealing with all of those difficulties, including having to have a chamber on the boat, not access to one on the shore. So we deliberately put this together, consulting with them rather than trying to hide from them, to make it a citizen science program utilizing hypoxic trained technical divers to achieve the results that the universities couldn't get by other means. So we had a good platform. The front of the boat has a huge storage area in the bow, and the university came on board and set up a laboratory there. So we were able to do everything whilst at sea. So the objectives: prove a concept that using CCR within the normoxic and hypoxic range could achieve genuine citizen science with results in the 40 to 100 meter range. So what we call technical diving, beyond recreational. To use photogrammetry to measure bryozoan and sponges. So basically to look at a sponge, make a 3D model of it, from that gather data, look at factors like its carbon sink capability, but more important, establish a baseline. So our next trip is planned for April again 2027, and we'll be able to go back to exactly the same spots and remodel the same bryozoan and see how much they've grown, changed, or if they've degraded, or maybe even disappear. Also taking samples. One of the scientists at one of the universities in the UK desperately wanted slivers. So we take a razor blade, we take the tiniest sliver off the sponge, put it in a sample tube, take it back, and they study it. The most important aspect was environmental DNA sampling. And rather than take these samples and at the end of the 9-day trip, go back, send these in the post to the university where some degradation may have occurred, the idea was, well, let's take the scientists with us. So you can see the size of this support vessel. The whole bow section, formerly the chain locker, was converted into a storage area. And you think technical divers turn up with a lot of equipment, with rebreathers, with 3 stages per person, with drop bottles of oxygen, with softener lime and all this stuff. The scientists brought about 3 times the amount of gear we did, including fridges and freezers and microscopes and everything. They turned the boat into a laboratory. We were diving live boat, which means the boat would take us close to a site, drop us, we would go down, do the dive, come up and decompress under delayed SMBs, and then be picked up. It's probably the biggest boat I've done genuine live boating from. It's quite daunting when this enormous thing comes towards you, standing meters above you, but it worked very, very well. And the other thing they wanted was Mesophotic zone video transects. So filming from the shallows, taking samples in the shallows, then going down to depth, video transecting the entire route so they could see the life forms changing as the depth changed, between either 6 or 7 meters when we were dropped in on a wall, or in one of the most amazing sites from deep water where the bottom started at 40 meters down to 100. And then we would take samples at our maximum depth. At each stage, filming on the computer so they could see where the sample was taken, at what depth, at what temperature, and log all of that to take the science one step further on board the ship. So this idea of merging diving methodologies, for decades, Scientific diving, media diving, recreational diving, commercial diving have stood in their own box. Little cells that don't communicate and don't talk. This started changing quite a while ago. Michael Mendino, he started this with the Rebreather forums. Forums where military, scientific, recreational divers were merging their technologies. The commander at the introduction yesterday said, now, you technical divers and manufacturers that support you are leading the way because you're building new systems that they are using. And as Kirk will explain to you in the next talk, what DEEP are trying to do is merge these technologies to enable scientific divers to achieve more. How we did that for this job, we add the safety of full face mask. With a full face mask, even if a diver became unresponsive, their face, mouth, nose are in an air pocket, so they have no risk of drowning. Secondly, one of the things that most of the commercial diving world insists on for a safe working project is communications. So that's the safety, obviously a big factor. But more importantly, if you're trying to do science, what if you've got the world's expert on bryozoans, but he's 75 years old and he wants to sit on the boat and do the studies? There's no chance he's going to dive to 100 meters in the Hebrides. He can be there on comms telling you what to do. You can tell him what you're seeing. And if you merge that with live video, suddenly you become an ROV with these things that no ROV or submersible or AUV or one atmosphere suit has yet achieved. The dexterous hand with the human mind and the human eye to see exactly what's going on. The beauty of this mask, because many of you with rebreathers might be thinking, okay, full face mask, bailout gets really complicated. The KM48, it's not the best looking thing. You're not going to win any fashion prizes, but you have an enormous pod that ratchets and comes out. So the pod is in place here on this photo. In this case, your rebreather, or it could be your scuba regulator, fits in through the front, and then you breathe as normal. The red section is the microphone, so you can use the comms, two-way, three-way, whatever is necessary. So diver to diver, diver to surface, surface to diver, etc. Should the rebreather fail, or any normal scenario where you need to bail out, you can close the rebreather loop, you can release the pod falls away, you put the bailout reg straight into your mouth. If you can resolve the problem, for example with an offboard flush, you can then put the rebreather mouthpiece back in your mouth, because inside this pod there is actually a mouth bite. You can then clear the rebreather, open it, and resume CCR breathing. You can then refit the pod and purge the water out of it, so you're back to full face and comms. And with a little bit of inventive modification, you can make these things semi-waterproof, but they're not the most expensive part. So it makes the diving a lot safer. This is actually from another citizen science job. It's very near to the location we talked, but it's between the islands of Jura, where very good whiskey comes from, and Skara, and it's known as the Gulf of Korriavekken. It's a whirlpool. There's the two biggest whirlpools in the world. One's in Norway, that Edgar Allan Poe wrote about in the Maelstrom, and one's in Korriavekken. The Royal Navy in the days of sail described it as unnavigable, because you get a standing wave 3 meters high and a whirlpool 3 meters deep. So you really need a good skipper to tell you what time of year you should dive this. Why does it do it? Because there's basically a 120 meter high shark's fin of rock between the open ocean and the inner channels. So these type of things can be achieved and done safely by using the right equipment, the right training, and most importantly, the right team who've trained together, practiced together, worked together, and not just the fun stuff, including starting with emergency drills. So the bryozoan photogrammetry, the bottom is a still from a 3D model with all the reference points, and there's the wee beastie itself. The scientists were really, really interested in these because some of the species aren't even supposed to exist off the western coast of the Hebrides. So firstly, we're finding them, filming them, that proves they're there. Secondly, we take very small samples with a razor blade, put them in a baggie, and label the depth. And then thirdly, our photogrammetry team would model the entire bryozoan. It's a complex shape, unsuitable for physical measurement. So a basic physical survey, you take a measure across and go, it's this wide, it's this long, it's this high. That doesn't really give you good data because it's such a complex shape. Photogrammetry, which can be done with something as simple as a GoPro. and training in photogrammetry from organizations like the Nautical Archaeological Society. They'll do a photogrammetry course with GoPros to teach you. You can do it with your own iPhone. It's very, very straightforward. It's the software that does the hard work, stitches all the images together to make a model. You can then spin it and analyze it. What they were able to do, like I say, I'm a dive safety officer, not a scientist, so the clever guys were able to take that photogrammetry and from it estimate the size and surface area and its skeletal weight, and therefore its CO2 absorption calculation. So this particular one, 0.79 kilos of CO2. So a great carbon sink, really important to the environment, really important to the atmosphere, and pretty much understudied. And here, able to study it alive in its natural environment. So we had these methods of sampling. Ignore the wrench, that was nothing to do with the sampling. But we would take sample tubes. They were sterile. At the surface, they were filled with seawater from the side of the boat, and then they were labeled up with numbers. They were preset. You have to fill them with water first, because if you take them down without water in them, you can't get them open, or if you're really deep, they collapse. And then we put them in a bag. We'd had the zip bags for the samples of the bryozoan, and we would basically take all that down and juggle it underwater. Now, you learn from your mistakes. So the first time you open the bag and they all float away. The second time you open the bag, take one out, thinking you're clever, unscrew the lid, and the lid floats away. So we practiced a lot in a freshwater training quarry until we got really good at this. And you're in dry gloves with undergloves, so it's just a thing to learn. The site we got to dive, the holy grail of the trip, didn't even have a name because it had never been dived. In that Hebridean Sea, there is a seamount. So from the surface of the ocean, you hit the top of this seamount at 40 meters of depth. So it's a deep recreational dive already. Now, to give you an idea of how rough the sea gets there, on the chart it says breaks in bad weather. So 40 meters deep, the sea hits it and makes a break, like a reef. So this is a big object in a bad sea. We didn't think we'd have any chance of diving it, but day 3 of the trip, the skipper said, right guys, we're on. We're going to the unknown. It's 40 meters at the top, it's 120 to 130 meters at the bottom, and all the way around are vertical walls. It's like Conan Doyle's Lost World. It's just, maybe we're going to find Jurassic Park dinosaurs down there. It was super exciting. So Tim, who has a penchant for incredible naming, he called it the edge of everywhere else. And it was basically X marks the spot. Middle of the Hebridean Sea, middle of nowhere, off we went. So basically for this one, we had a downline, boat dropped us on the downline, went down, the top is just covered with profuse kelp. Absolutely beautiful. The visibility there, because it's so remote, deep water, 20, 30 meters of visibility. We work our way to the edge and start to drop down, and it is literally a vertical wall. And I've not seen life like that since the Caribbean. There's literally soft corals, soft sponges, hard corals, all the way down the wall, literally a profusion of color. So when we got down there, here's actually footage of Tim. You can tell because he's got coobies, and he's basically got a paint scraper. So in citizen science, you get inventive. You don't need thousands of pounds worth of tool. You use what works. Taking the sample, put him in a bag, and bringing those up. These sponge samples were used to send off to one particular specialist who wanted to research them. And this is how we did the sediment sampling. So here, most importantly, we're taking a sample with 3 syringes. The way you use the syringe is you basically hold it still and push the syringe down into the sediment so your hand disappears, rather than pulling the plunger. Once you've done it, you then reach in, put a cap on the end, bring it out. You film, this one's just under 70 meters, exactly what depth it was taken. You then scroll through the shearwater menu and get the temperature it was taken. We do this at the highest point on the wall or the seamount, so 6 or 40 meters, depending on the site. And then you do it at the deepest point on that particular dive, this one, a normoxic depth range. And then they're able to take an eDNA sample from the shallow ones to deep ones and look at differences. Now, some of this sediment in the 70, 80, and 90 meter range, about 5-6 centimeters depth, has been there for hundreds of thousands of years, and that's what they're interested in. So sampling undived sites, comparing depths on the same site, so different data. And as you can see around the samples, just profusion of life absolutely everywhere. One of the sites we dived towards the end of the trip was basically an inshore site. It's a sea loch called Loch Nevis, and that gave us some of our best results. We dived the edge of it in the area where there was significant salt water, but it gave us the ability to dive in the slightly rougher weather. You can see there, pretty good for the west coast of Scotland. Even on a bad day, we're getting pretty good conditions there, but it's beautiful territory. As we said, the front of the boat was turned into a lab. They bought their own fridge. They bought their own air and clean water lines. They bought all the necessary ingredients to make everything sterile. And what basically happened was we'd finish the second dive of the day, one per team, get out, brief the scientists, have our evening meal together, then we'd go to bed, they'd go to work. They'd work the night shift and run these samples. At breakfast time, they're just about ready to go to bed. The first morning after they'd sampled, nobody thought we would get anything. They came up with this, and they were dancing and dancing and dancing. They were so excited. They said, day one, we got intact eDNA from 70 meters from a 10 centimeter depth in the sediment. And they said, that's good. How many did you get then? Like, was that one? They said, no, in excess of 1 million on the first day. So this is going to be a peer-reviewed paper. They're already starting to write it. It's new science, never achieved before. You see the delicacy of those sediment samples can't be done with an ROV manipulator. There's no previous diver video of some of these sites. This is what I was talking about, the profusion of life, the profusion of color. And this is the UK. Everyone says don't dive in the UK, it's awful. This diving was absolutely amazing. We regularly had seals on decompression, not just there passing, playing with us. Like, what are you two doing, hanging on that rope, you silly things? You don't look very sensible. Swimming around us, diving between us. So absolutely incredible. The diver beats a drop camera, an ROV, an AUV, because you have the human in situ judging the environment and the habitat. That is the sort of conditions we got for 9 days in the Hebridean Sea. I don't think my life will be long enough to ever see that again. I've dived up there many times, sat on the shore many times, not able to dive, but the Goldilocks moment, when it's like that and you're achieving something. And I really think that the future, and we're going to talk about this on this afternoon's panel, of getting young people involved and making diving as cool again as it was when I was young, and that was a very long time ago, when you sat and watched Cousteau with your dad and went, I want to do that, is getting people something to do and welcome them into maritime archaeology projects like the Swedish Wreck Museum are doing, the scientific projects like this. And as was told yesterday, this can be kids in 50 centimeters water counting snails. It can be big kids in 100 meters of water on a rebreather. Everyone can get involved and everyone should. Thank you very much.